Hello, we're going to solve this equation. X squared plus 4 times y prime plus 3xy equals x. Here we have initial condition y0 equals 1. This is a linear equation, but it's not in standard form. We have to divide by x squared plus 4 to bring it to standard form. Divide throughout by x squared plus 4. We get y prime 3x x squared plus 4 times y equals x squared plus 4. And now this is a linear equation in standard form. The coefficient in front of y is this. That's px, and here we have qx. In the next step, we shall compute the integrating factor. Integrating factor will be exponential integral px dx, so we write 3x x squared plus 4 here dx, and then we have to evaluate this integral. And this integral we evaluate using the substitution u equals x squared plus 4, so du will be 2x dx. We can replace directly x dx. This product is over there, so we write x dx is 1/2 du. Well, now the integral changes this way. Exponential, there is a coefficient 3, then divide by 2. Let's put this outside. 3/2 integral 1/u du. And this will be exponential 3/2 logarithm u. This will be exponential logarithm u power 3/2, and finally this is u power 3/2. Now remember what is u. We have x squared plus 4 power 3/2. This is our integrating factor. We multiply the standard form of the equation by this integrating factor. This is the standard form of the equation. So we multiply both sides throughout by x squared plus 4 power 3/2. What is the result of this multiplication? On the left side we have y prime multiplied by x squared plus 4 power 3/2, plus in the middle we have 3x x squared plus 4. Now we have 3/2 here on top and x squared plus 4 negative first power, so we have to reduce, and this becomes 1/2, and then y. On the right side there will be x squared plus 4 x squared plus 4, 3/2 minus 1, again 1/2. Well, on the left side of the equation we have one exact derivative. This is the derivative y x squared plus 4 power 3/2. All this prime equals this expression. Let's check using the product rule. If we apply the product rule to this function here, this product, we have y prime with the second factor, then y, the derivative of x squared plus 4 3/2. Let's see what is this derivative. X squared plus 4 3/2 prime. This is 3/2 x squared plus 4, subtract 1 here, 1/2, and by chain rule differentiate inside, you have 2x. Reducing by 2, this will be x, actually this will be 3 times x squared plus 4, 1/2, and 1 more x here. And that's what we have in this place, exactly. That's the derivative. Also, pay attention on the right-hand side. This is the same derivative, only one factor 3 is missing. So I can rewrite the entire equation this way. Y x squared plus 4 3/2 prime equals, here multiply, divide by 3, so this will be 1/3 x squared plus 4 1/2 power, all this prime. This is what we have, and this is the derivative of 3/2 here, sorry. Correction, 3/2. The derivative of x squared plus 4 3/2 is written here. This is it. When we divide by 3, it's exactly right hand side. Okay, our original equation is written now in this way. One derivative equals another derivative. So we can compare, we can integrate both sides, and the result will be y x squared plus 4 power 3/2 equals 1/3, again x squared plus 4 3/2 and plus c. So these two functions have the same derivative, they differ by constant. That's a basic fact on calculus. So with this work, with this integration here, we found the general solution. This is the general solution. It's not written in a very convenient form. Now we have to solve for y. So we divide both sides by x squared plus 4 power 3/2. Divide both sides by this integrating factor, and the result will be y equals 1/3 plus c over x squared plus 4 3/2. This is the general solution. Well, computational problem, but such things happen. Now we need to remember our initial condition. Y of 0 equals 1. So we set x equals 0, y equals 1. What will be the result here? 1 equals 1/3 plus c 4 power 3/2. 4 power 3/2 we can compute without calculator. 4 power 3/2 we can write 4 power 1/2 cubed. So this will be 2 cubed, that's 8. So the equation that we have for c is 1 equals 1/3 plus c over 8. Solving for c. C over 8 equals 1/3 minus 1 minus 1/3 is 2/3. So c will be 16/3. Finally, we can write our solution. Y equals 1/3 Here we write 16 and this 3 in denominator, x squared plus 4 power 3/2. Look at this solution. It's a function which satisfies the differential equation when x is 0, y equals 1. We can compute here when x is 0, this will be 16 over 8, which is 2. 1/3 plus 2/3 is 3/3, is just 1. Everything is fine. Also, pay attention to the general solution here. C is an arbitrary constant. If C is 0, y equals 1/3 is a very special solution. From the general solution, when C equals 0, the function 1/3, just this constant, is a solution, which can be verified directly in the original equation. If you substitute y by 1/3, you get x equals x, which is true. So that's a very special, simple solution. Okay, thank you for the attention.